Okay, so if b is greater than 1, this is exponential growth, and it's increasing. And if it's between 0 and 1, it should say between 0 and 1. It's exponential decay. And it's decreasing. Okay. So no matter what happens, you either start out with a low number and you grow, or you start out with a big number and you decrease with decay. You're never going to take a positive base, raise it to a power, and then get a negative number. There's no way, right? You can't take 2 to a power and get a negative number, right? Yeah? What's 2 to the negative 2?
4.
1/4.
4.
2 to the negative 2 is 1/4. If I did 2 to the 1/2, well, that's the square root of 2. That's like 1.4-ish. So I'm never going to be able to get negative numbers. So because of that, my graph will have something called an asymptote, okay? This is a line that my graph will approach as it goes out to infinity, okay? So this is a line that my graph will approach as it goes out to, and it could be either positive or negative infinity, just depending on if it's growth or decay. So as it approaches one of those two. Okay, have we talked about asymptotes before in this class? We have? When did we, what? It was last mod. Did we do rational functions? Is that when? I can't remember what we've done yet. A line that my graph will approach as it goes out to plus or minus infinity. Okay. All right, so f of x is equal 2 to the x. 2 is a number bigger than 1, so therefore this would be exponential growth. Okay. All right, so the first thing I want to do is get just kind of like a nice little set of points. Okay, I know we've talked about this before. I don't want you making tables when you graph points, right? Transformations, you shouldn't just like plug in some x's and get some y's. But I'm going to show you there's really 3 key points or 3 key features of an exponential graph that you want to have. So the first is what you get when you plug in 0, 1, and then you're going to have your asymptote. So just 2 points, right? 0 and 1. So if we plug in 0 for x, what is 2 to the 0? 1. Okay. All right, now if I plug in a 1 for x, what's 2 to the 1? 2. Okay. So I could keep going, but I don't really need to. I know this graph is going to grow. Okay. What would happen if I plugged in a negative 1? What's 2 to the negative 1? 1/2. You guys remember negative exponents take the reciprocal of that number. So 2 to the negative 1 is a 1/2, so it gets like closer here. And if I were to keep going out, it would get closer and closer and closer to that axis. And so it would really create a horizontal asymptote here on the x-axis. And then I'm not going to put it in the table, but I could do like, x equals 2. And it would be 2 to the 2, which would be 4. Then I could do 2 to the 3, and it would be 8. And so it's going to grow like that. So this graph ends up looking like this. Okay? So there's 3 key features to this parent function graph. So you're going to get the point that you get when you plug in 0, the point you get when you plug in 1, and then your horizontal asymptote is y equals 0. So my domain of this function is all real numbers. I could plug in any value for x and get something out, right? And so you can see that this graph goes all the way to the left, and all the way to the right. So it includes all real numbers. But the range does not include all real numbers. This graph goes all the way up towards infinity, but it levels out at the x-axis. So what kind of y values do we get with this graph? What kind of y values do we get? Only positive numbers. So the kind of numbers that are positive are y values that are greater than or equal to 0. So if you remember, we had this set notation way of writing it. Okay, now end behavior. So as x goes to infinity. As x goes to infinity means as we move to the right. So as we move to the right in the graph, what is my graph doing? It's going up, right? It's going up. So my y values are going up to infinity. And then as we go to negative infinity, that's to the left, my y values really flatten out and they go down to 0. Okay? Horizontal asymptote is y equals 0. Y equals 0 is a horizontal line. Okay? All right, so we had a y-intercept at 0, 1, and we had an asymptote at y equals 0. Okay? So, notice that this line right here, okay, where I have a y values leveling out at 0, that tells me that I will have an asymptote at y equals 0. Okay? So that's actually technically the definition of a horizontal asymptote, is that it's the values that the graph will approach as you go out to either positive or negative infinity. Okay, so that is a parent function. Okay, let's do another parent function. Y is equal to 3 to the x. Okay, is this exponential growth or decay? Growth. This one's also going to grow. Okay, so just 2 points and an asymptote are needed to give me a good idea of what this graph looks like. So I'm going to plug in 0 and 1. If I plug in 0, what do I get for y? What's 3 to the 0th power? 1. Oh, that's the same as last time, isn't it? Yeah, it's always going to be that way. All of them. All the parent graphs. Okay? And what do we get when we plug in a 1? 3 to the 1 is 3. And there's also kind of like a similar pattern here. The number you get when you plug in 1 is always whatever the base is. So whatever that base is, if it was 2 in the previous problem, it's 3 in this one. And then we will have a horizontal asymptote of y equals 0 again.
So is that like always a rule?
For a parent, yes, for a parent function. Okay, so 0, 1, 1, 3, and it looks exponential, so it's going to do kind of like this. Okay. Domain, same as before, all real numbers. Another way of writing that is from negative infinity to positive infinity. Okay, range is all the positive numbers. Another way of writing that is from 0 to infinity. You guys might remember.
So you would take anything? Either?
Yes, I'll take either one. They're both correct. Okay. Yes, Inez.
How do you know the horizontal asymptote is
So y equals 0 is the line that these numbers are going to get closer and closer to, but never cross because they can't be negative, right? All the y values down here are negative, and all the y values of here are positive. And so it's going to remain positive, though very small. Okay, so my end behavior is also the same. It's going to infinity and 0. Y-intercept, again, 0, 1. And my asymptote is y equals 0. So for all of these parent functions that are exponential growth, this stuff over here on the side looks identical, right? And there's really not much different about this graph, except that it grows a lot more quickly down here because it has it triples rather than doubles, right? Something that triples over time is going to grow more quickly. Okay? All right. So now, f of x equals 1/2 to the x. What kind of exponential function is this? Decreasing, which we call decay. Uh-oh. My screen might be freezing. I'm not sure. No, okay. So same idea as before. I'm just going to plug in 2 points. If I plug in 0, any number to the 0th power is going to be 1. When I plug in a 1 for the exponent, what's 1/2 to the 1? 1/2. Okay, and then I will have a horizontal asymptote of y equals 0 again. Do you feel like that's enough points for us to know what that looks like? Maybe, what if I plug in -1? What would 1/2 to the -1 be? Remember, when I have a negative exponent, it tells me to flip the 2. So if I had a -1, it would be a 2. What if it had been a -2? So 1/2 to the -2. What would that be? Yep. Good. Okay, now are you feeling better about this graph? If I plugged in a 2, it would be like a 1/4, which is like so low, right? Okay, so it's starting to look like this. But for my purposes and for your graphing purposes by hand, 2 points is really all you need, right? That intercept and then that additional point. So that'll tell you enough. That'll tell you that it's decay, right? Okay, so domain, still all real numbers. Range. What about the range? Yep, 0 to infinity again. Okay, as x goes to infinity, that's to the right. As x goes to the right, what are the y values doing on this graph? They're going to 0. And then as x goes to -infinity, that's to the left. Where are the y values going? They're going up to infinity. Right, okay. So this one, the end behavior for this is swapped from an exponential growth. Okay, so decays will go to 0 as you go to the right. Okay, but y-intercept, still the same, still 0, 1. And asymptote, still y equals 0. Okay, all right. Okay, do you feel like we need to do 4 and 5? Okay, I'll have you guys do number 4. And then I'll check in just a second. So first of all, is this growth or decay? Decay. Okay, good. Okay, so it looks something like that. It's very similar to number 3, right? It's very similar to the exponential decay where we had a 1/2. So in this case, the rate at which it quote unquote grows is a little bit bigger than the 1/2. So it would technically not look quite so flat. It would look a little bit steeper off to the left-hand side. Okay, and then this last one on this page is 5/2 to the x. And it's not there as a trick, but it's there to make you remember that just because you have a fraction there doesn't mean you have decay. 5/2 is a number bigger than 1. It's actually around 2.5. And so this is growth. Okay, so it's going to look really similar to the other ones. I know I'm going to have the 0.01, and then I'm going to have the 0.1 comma 5/2. So it'll be 1, 2.5. And then from there, it will be increasing. And I'll have a horizontal asymptote. So I would have the 0.01, I would have the 0.1 5/2, and then I would have y equals 0 as my horizontal asymptote. Make sure that when you write the asymptote out, you write it as a y equals, because it's a line. And lines need to be expressed as equations. Okay, so y equals 0 is what you're going to write down for your asymptote. And it's a y equals because it's a horizontal line. Horizontal lines are of the form y equals and then just the number. Okay, so these are the parent functions, or these are examples of the parent functions for exponential decay, growth and decay. Okay, so what we're going to do now is add in transformations. So let me just really quickly write out what we know for parent functions. Parent functions for exponential. Okay, they look like y equals b to the x. And they will always contain the 0.01. They will always contain the 0.1b. And they will always have a horizontal asymptote of y equals 0. The domain is always all reals. And the range is always positive numbers. Okay? Does that make sense? For parent functions. Okay, so I say that because I'm going to show you when that's not always the case, but it's always true for parent functions. Okay, so we can transform a function by putting a number in front of it and multiplying. We could add or subtract a number in the exponent, or we could add or subtract a number on the outside of the exponential term. Okay, so those transformations happen like this, right? I could multiply by a number in front, I could add or subtract a number in the exponent, or I could add or subtract a number on the outside of this term. Okay, so H is the horizontal shift. So anything that occurs with the X, sort of inside the group with the X's, that's a horizontal movement. So this would be the horizontal shift. So a positive number would actually go to the left, and a negative number goes to the right because horizontal transformations go in like the opposite direction of the sign. K is a vertical shift, and vertical transformations do what you expect, okay? So a positive number would indicate a movement up, and a negative number would indicate a movement down. Maybe behind the refrigerator. Okay, if A is negative, then the function is reflected across the x-axis. And if it's a number bigger than 1, it'll be a vertical stretch. If it's a number between 0 and 1, it'll be a vertical compression or shrink, just depending on whether or not your textbook uses a certain kind of lingo. Is some of this seeming familiar to you guys?
Yes.
That's good. I'm glad. Okay, so it's the same types of movements, left, right, up, down, stretch, shrink, as all the other functions that we've done before this year. Okay, so for right now, we are just going to, for these couple problems, we're just going to identify the parent function, and then we'll describe the transformation in words. And then later on, we'll actually get to graphing the transformation. Okay, so what's the parent function here? The parent function is y equals 3 to the x. Good. And then what is that plus 5 going to do to that function? Shift it up or down. In which way, Inez? Is it going to be up or is it going to be down? Yep, exactly. So it's going to be shifted, shift up, shift up 5. Okay. So it would take the graph that we did in number 2, and it would just take all of the values, everything, it would shift it up 5. So it would change the horizontal asymptote, it would change the y-intercept, and it would change every other point that's there. Okay, so f of x equals 2 to the 1/4 x minus 1. What's the parent function? Yeah, very good. Y equals 1/4 to the x. And so we have 2 different transformations happening here. We have the 2 and the negative 1. Let's start with the, the 2. What is the 2 going to do? Stretch. Vertical stretch by 2. And this changes what kind of values? X or Y values? Yeah, so all it does is it multiplies the Y values by 2. Okay, that's what a vertical stretch does. It multiplies the Y values by 2. And then we also have that negative 1. What's happening there? Yeah, moving to the left or right. In this case, it's to the right because that number is negative. So horizontal shift right 1. Okay, so you might recall that horizontal shifts change the x values. So we would be adding 1 to the x values, which would definitely change the location of our x and y intercept, or excuse me, y intercepts. The horizontal shift wouldn't change an asymptote though, right? If you take a horizontal line and you move it, it's still the same horizontal line. So it's not going to change everything. All right, so let me go ahead and have you do a quick practice on 3 and 4. And just identify what those changes are going to be. through what you got for number 3. So what was the parent function? Okay, good. 4/3 to the x. Is this a growth or a decay? Growth. Very good. Okay, so the negative in front would be a reflected over the x-axis. Now, another way of saying this is that you make the y values negative, or you negate the y values, okay? So reflect over the x-axis, you'd be going up 7, which is like adding 7 to the y values. And then you'd be going to the left 2. So you'd be subtracting 2 from x values. Okay. All right, and number 4, what's the parent? 5 to the x, good. And so we had a vertical compression here by 1/2. You'd be going to the right 4 units, and then you'd be going down 2. Okay. All right, so hopefully these transformations are coming back to you and you're starting to remember these different things. Ines.
For x plus 2, I thought we were adding 2 to the x value.
No. So horizontal transformations do the opposite of what you think they should do.
Oh, right.
Anything horizontal will go in the other direction. Yeah.
I forgot. Inside the parentheses is like
Inside the parentheses. Now, so parentheses is one grouping symbol, but you don't want to necessarily just think of parentheses as the only grouping symbol. So for example, an exponent, everything up in the exponent is its own group. So that's a grouping symbol in itself. Or like if it was a fraction bar, like a fraction bar would be a grouping symbol too. So don't just look for parentheses. But yeah, you're right. In the previous functions that we've done it with, parentheses would be what we'd normally see. Okay, so this graph, it has a parent function of y equals 2 to the x. So in the parent function, we're going to have the point 0, 1, and we're also going to have the point 1, 2. And then we're going to also have, finally, the horizontal asymptote at y equals 0. Okay, so that's what the parent function will have, 2 to the x. And how is this graph going to be different than the parent? What's the transformation? Left 5. We're going to go left 5. Okay. All right, so if I'm moving things to the left 5, I'm only changing the x values. So only this 0 and this 1 are going to be different. Everything else is going to remain the same. So I'll still have a 1 here, I'll still have a 2 here, and I'll still have a y equals 0, because y equals 0 is a y value, right? So I'm going to move everything to the left 5, so 0 becomes -5, and 1 becomes -4. Okay, so then what I graph here is going to be this. Okay, so I'm going to graph the point, -5, 1, and -4, 2. And so this graph is going to be doing this. So my domain remains the same. It's all real numbers. My range is still 0 to infinity. My end behavior, as I go to the right, it's moving up. As I go to the left, it's going down and flattening out. Ooh, y-intercept. I actually don't know what it is. I can't tell by looking yet. So I'm going to come back to that in a second. And then my asymptote is y equals 0. Okay, so I need to get information about the y-intercept. So I can't tell just by my table of points where it is. And I'm not even trusting exactly how well I drew that graph to even say that it's like, oh, it's around 11, right? I really don't know. So what do I know about y-intercepts? What is the x value at the y-intercept? It's when x equals 0. So what I can do with this is I can just take my graph, which is f of x equals 2 to the x plus 5, and I can just plug 0 in. So I'm going to do f of 0. So that would be 2 to the 0 plus 5, which is 2 to the 5th, which is 2 to the 1 is 2, 2 to the 2 is 4, 2 to the 3 is 8, 2 to the 4 is 16, so 2 to the 5th is 32. Oh yeah, it's way up there. So 0, 32. So definitely my graph should be a lot steeper. It's still fine for just like a rough sketch of a graph, but now that I know it's 32, I'm going to try and make it a little bit more like that. Okay, so but that's what the y-intercept is. So if you can't tell what the y-intercept is just from your table of points, then you need to go ahead and plug 0 in to the function to get what that value should be. Okay? All right, so 6. My parent function is an exponential decay. It's y equals 1/3 to the x. So it's going to have the points 0, 1 and 1, 1/3. And then it will also contain the point y equals 0. Now my transformed function is going to be taking things and moving them down 2. Okay. So f of x is being moved down 2. That means I'm going to be changing the y values. This is a vertical shift. So it only changes the y values, the vertical values. Okay, so everything that's an x value stays the same. Those stay the same. But anything that's a y value is going to move. Okay. So in order to get that y value down to, I'm just going to subtract 2 from each number. So 1 minus 2 is -1. And then down here at the bottom, 0 minus 2 is -2. Fractions. 1/3. Oh, -5/3, yeah. Or we could think of that as -1 2/3. All right, so I've got to graph this now. So y equals -2 is my horizontal asymptote. 0, -1. And that is my y-intercept, right? It's on the y-axis. And then 1, -5/3. So it's going down. It's decay. We'd already said it was decay. Okay, so it's going to look something like this. All right, so domain, all real numbers. My range, it's not just positive values though. Now, where is my range? 2, -2, yeah, -2 to infinity. So it's everything above that asymptote in this case. Okay, so as x goes to infinity, so as we move out to the right, the y values are approaching my horizontal asymptote, which is down at -2. And then as we go to the left, as x goes to -infinity, my graph is moving up. And so that's why those y values up there are approaching infinity. Okay, I already have my y-intercept. It's at 0, -1. And then my asymptote was y equals -2. Okay, how's this going for you guys? Is it making sense? Okay, I'm going to do one more with you, and then I'm going to have you do 2 on your own. So I'm going to pick maybe number 9 to do with you, just because it has that reflection in front. Okay, so the parent function for this graph, the parent function is going to be y equals 4 to the x. Okay, so that would contain the point 0, 1, 1, 4, and y equals 0. This graph, it has a couple of different transformations. So it's being moved down 2, excuse me, not down. It's being moved to the right 2. Okay, so that's going to change my x values. So my x values are going to be moved to the left 2 units. So this would become a -2. This would become a -1. Hold on. Let me think. Let me use my brain. Moving to the right 2. Yes, adding 2. Thank you. So this should be a 2 and this should be a 3. Good catch. Okay. And then this other transformation is kind of like 2 transformations in one. It's going to be a vertical stretch and it's going to be a reflection, but you can handle them as one individual step because no matter what, I'm just taking and multiplying the y values by this number. So I'm just multiplying both, all y values by -2. You could multiply it by a negative and then multiply by 2, but why would you do all that work, right? Just multiply by -2. So 1 times -2 is -2. 4 times -2 is -8. And 0 times -2 is still 0. Okay, so when I go to graph this, I'm going to start with my horizontal asymptote here along the x-axis. 2, -2 is right here, and 3, -8 is right here. So I know this graph is going to be approaching my asymptote out here to the left. Okay? So asymptotes aren't, as a rule, lines that we can't cross. But in general, for these types of functions, you won't cross the asymptote. Okay, so I think it's really important to not have it in your mind that, oh, asymptotes are lines you don't cross. That is true for certain types of functions. For exponential functions, that is true, but not for all functions. Okay, so my domain for any of these is going to be all real numbers. My range in this case now is actually everything below the x-axis. So that's from -infinity to 0. Does that make sense, y'all? Okay. Remember, you always put the lower number first. You're not going to do 0, -infinity. Always put the lower number first. Okay? As x goes to the right-hand side, so as it goes to the right, f of x goes down to -infinity. And as we move to the left, the graph's y values are approaching 0. I don't know what the y-intercept is. I'm going to come back to that in a second. But I can tell that the that the asymptote is y equals 0. So for my y-intercept, I'm going to be just plugging in 0 for x. So I'm doing f of 0. In this case, it would be -2 times 4 to the 0 minus 2. So -2 times 4 to the -2. Ooh, what's 4 to the -2? 1/16. So when you do this in your head, I want you to do 4 to the 2, which is 16, and then the negative is the reciprocal of that. So 16 reciprocal is 1/16. Okay. So then when I multiply a fraction times a number, that 2 is like saying 2 over 1. So it would be -2 times 1 over 1 times 16. And then this does reduce to a -1/8. Whew. So my intercept is 0, -1/8. Yes, Julia.
Is this like the parent function was a growth, but then now we call it a decay?
So it's some textbooks call it decay and some don't. So I hesitate to give you like a hard and fast yes or no. But yes, there are definitely some textbooks that would call this decay. All right. Okay, so I would like for you and your partners at your table to work through numbers 7 and 8, and then we'll check those in just a couple of minutes. We'll do 5 minutes. Oh, on number 7, I should ask you this question real quick. So both of those transformations are vertical, right? So you've got a multiplication by 1/2 and you've got an adding 1. Those are both happening to the y values. Which one do you do first?
1/2.
Yeah, multiply first. Because remember, in your order of operations, GEMDOS, the multiplication or the division comes before the addition or the subtraction. Okay, so if you were plugging a number in and simplifying the expression, you would do the multiplication first. So do the multiplication first before you do the plus 1. Okay? Okay, so let's go ahead and check what you've got. So for number 7, the parent function is y equals 3 to the x. So the parent function would contain the point 0, 1, 1, 3, and y equals 0. This transformation is going to move everything up 1, and it's going to vertically compress things by 1/2. So the x values do not change. There's no horizontal transformation here. But there are 2 vertical transformations, and I need to impose the vertical compression first, and then the vertical stretch. So I'm going to take this y value and multiply it by 1/2 first, then add 1. So 1 times 1/2 is 1/2. 1/2 plus 1 is 1/2, or 3/2. Okay, 3 times 1/2 is 3/2, and then 3/2 plus 1 is 5/2. So you end up with this function right here. I'm going to just talk for another 30 seconds, and then we'll have our espacio. Okay, so then for number 8, the parent function is y equals 3/2. This is exponential growth as well, but I have 2 different transformations here. One of them is horizontal, so that's moving everything to the right 4 units, and the other is vertical, and that's shifting everything down by 5 units. The y-intercept, you have to use your calculator to get a nice improper fraction. And so you just plug that in, and you'll get negative 389/81. I know that's hard to read. Yep, so you could just do 3/2 to the negative 4 minus 5. And then you do math, frac.